Our next example, consider this function. 2x subtract 3 all over x squared plus 2x subtract 3. Show that the derivative is equal to this and draw its sign diagram. Okay, so we need to show the derivative. Let's take a look at this. We're going to be using the quotient rule. It's a good review about this. And let's see if that's what we started with. Minus 2x times x minus 3 all over that denominator. Yes. Okay, so we're finished part A. Part B, hence find the interval. Oh, and draw its sign diagram. Ha. So we need to draw the sign diagram for this guy. Okay, so zeros will occur when this function is equal to 0. So let's think about when that would happen. 0 equals this function. Once we cross multiply, this denominator will disappear. Okay, so in other words, the zeros are going to be whatever causes the numerator to be 0. So zeros are 0 and 3. Asymptotes are whatever causes the denominator to be 0, because that will make it undefined. So that will be 1 and negative 3. So the sign diagram has 4 critical values. Negative 3 is an asymptote. 0 is a 0. 1 is an asymptote. And 3 is a 0. And this function, is it increasing? This derivative function, is it increasing or decreasing in each of these intervals? So choose something smaller than negative 4, smaller than negative 3. So negative 4. So we're working with this. And we plug negative 4 in there. This numerator will be a negative number. This denominator will be a positive number. So therefore, that's a negative number. So negative. Okay, I'm running out of room, so I'm going to erase this and do another one. Looking for an interval between negative 3 and 0. Let's choose negative 1. That's a negative times a negative times a negative in the numerator, so that'll be a negative. It's a positive times a positive in the denominator, so again, this is negative. Number in between 0 and 1. 1/2. This will result in a negative, positive, negative. So that's a positive number in the numerator divided by a positive number in the denominator. That equals a positive number. Number in between 1 and 3 is 2. Negative times a positive times a negative, that's positive. And this is a positive, so positive. And a number bigger than 3. Number bigger than 3, so 4. negative times positive is a negative in the numerator, positive in the denominator. That is negative. Okay, check and see if we've answered the question. Find the intervals where the function is increasing or decreasing, the original function. When we're answering this question, which intervals are increasing and decreasing, if we have asymptotes here, we need to be careful because the asymptotes are not part of the domain. So keep that in mind. The asymptotes are not part of the domain. So therefore, when we're stating where this function is decreasing, we have to list this section separate from this section. And of course, this section over here is also separate. But because this asymptote is here, we cannot lump these two intervals together. So we can say it's decreasing when x is less than 3, and it's decreasing from 3 less than x less than or equal to 0. Okay, so it does include 0, does not include 3. We can also say when, oh, that should have been a negative 3, sorry. And when x is greater than or equal to positive 3. This function is increasing. Again, there's an asymptote in the middle of these two increasing intervals, so we cannot lump them together. It's increasing from x is less than or equal to 0, is less than 1, not including the 1, and also x is less than 1, less than or equal to 3. Okay, so extra little bit of information is given to us based on the way that those intervals are stated.